Today is day 13 of Advent of Cyber 2025, and today's challenge is called YARA Rules. YARA mean 1. When McSkitty went missing, there was chaos and uncertainty at the Best Festival company. However, even in her disappearance, McSkitty was trying to help the TBFC Blue Team, taking a page out of the crisis communication process. McSkitty sent what looks like a bunch of images to the Blue Team from an anonymous location. These images look like they were related to Easter preparations, but they contained a message sent by McSkitty. The crisis communication process outlines that a message might be sent through a folder of images containing hidden messages that can be decoded if you know the keyword. The Blue Team has to create a YARA rule that runs on the directory containing the images. The YARA rule must trigger on a keyword followed by a code word. After extracting all the code words in ascending order, the Blue Team will be able to decode the message. The learning objectives for this are to understand the basics of YARA, learn when and why we need to use YARA rules, explore different types of YARA rules, learn how to write YARA rules, and practically detect malicious indicators using YARA. So for this challenge, we start the virtual machine and it will open up in split screen view. At this stage, McSkitty, the lead defender, has entrusted you with a mission involving the use of YARA rules. Before jumping into action, let's take a closer look at what YARA is, how it works, and why it's such a valuable tool in the TBFC's fight to protect SOCMUS. YARA is a tool built to identify and classify malware by searching for unique patterns, the digital fingerprints left behind by attackers. Imagine it as detective's notebook for cyber defenders. Instead of dusting for prints, YARA scans code, files, and memory for subtle traces that reveals a threat identity. Within TBFC, YARA serves as a silent guardian, scanning through systems and uncovering the faintest trace of malicious activity that others might overlook. Now, as snow drifts over Wereville and the SOCMUS network trembles under threat, it's your turn to wield this tool and restore the balance. You might wonder why McSkitty chose this tool for the mission. In the world of cyber attacks, defenders face an endless stream of alerts, suspicious files, and anomalous network fragments. Not every threat stands out. Some hide in plain sight, disguised as harmless documents or scripts. That's where YARA shines. YARA gives defenders the power to detect malware by its behavior and patterns. Not just by name, YARA allows you to define your own rules, providing your own view of what constitutes malicious behavior. And you're not alone. Many YARA rules have already been written by defenders from other kingdoms who once faced similar threats. You can use, adapt, and improve these shared rules to strengthen TBFC's defenses and protect SOCMUS together. For the defenders of SOCMUS, this means faster detection, smarter hunts, and fewer threats slipping by unseen. So in what situations might defenders rely on this tool? Post-incident analysis. When this security team needs to verify whether traces of malware found on one compromised host still exists elsewhere in the environment. Threat hunting, searching through systems and endpoints for signs of known or related malware families. Intelligence-based scanning, applying shared YARA rules from other defenders or kingdoms to detect new indicators of compromise. And memory analysis, examining active processes in a memory dump for malicious code fragments. YARA values. The constant battle to protect SOCMUS, time and precision matter most. That's where YARA shows its true value. It gives defenders clarity in chaos. With YARA, you're not waiting for an antivirus update or third-party alert. You have the power to create your own rules, detect new variants, and act before the threat spreads. For TBFC's defenders, YARA brings several key advantages. Speed. Quickly scans large sets of files or systems to identify suspicious ones. Flexibility. Detects everything from text strings to binary patterns and complex logic. Control. Lets analysts define exactly what they consider malicious. Shareability. Rules can be reused and improved by other defenders across kingdoms. Visibility. Helps connect scattered clues into a clear picture of the attack. In short, YARA empowers defenders to move from passive monitoring to active hunting, turning intelligence into action before the attackers strike again. Now that we understand what YARA is and when to use it, it's time to see how it actually works, to uncover the digital footprints of the evil king Malheur. A YARA rule is built from several key elements. Metadata. Information about the rule itself, who created it, when and for what purpose. Strings. The clues YARA searches for. Text, byte sequences, or regular expressions that mark suspicious content. Conditions. The logic that decides when the rule triggers, combining multiple strings or parameters into a single detection. And here's how it looks in practice. So we've got the rule TBFC King Malheur Trace. We know that was created by a defender of SOCMUS. It detects traces of King Malheur's malware. And for this rule to trigger, we're looking for run dll32.exe, msvcrt.dll, and URL of http:/, and if it contains malheur. Then it would trigger. So the condition is any of them. So if any of these rules are met, then the rule will trigger. Strings are the clues that YARA searches for when scanning files, memory, or other data sources. They represent the signatures of malicious activity in fragments of text, bytes, or patterns that can reveal the presence of King Malware's code. In YARA, there are 3 main types of strings, each with its own purpose. Let's talk about them and see how they can help defend the kingdom of TBFC. So we have text strings, and they are the simplest and most common type used in YARA rules. They represent words or short text fragments that might appear in file, script, or memory. By default, YARA treats text strings as ASCII and case sensitive, but you can modify how they behave using special modifiers. Small keywords added after the string definition. Example below shows a simple rule that searches for the word Christmas inside a file. So within the rule, we've got strings, and string specifically is Christmas, and the condition is the string variable created. So case insensitive strings, by default, YARA matches text exactly as written. If you add no case at the end, like here, then it doesn't matter if how the word Christmas is spelled, whether it's uppercase or lowercase. If it matches at all, regardless of case, then it triggers the rule. Wide character strings, wide ASCII. Many Windows executables use 2-byte Unicode characters. Adding wide tells YARA to also look for this format, while ASCII enforces a single byte search, which can be used together. So a search for Christmas in both the Windows executable 2-byte Unicode and ASCII. XOR strings. Malware's agents often XOR encode text to hide it from scanners. So using the XOR modifier, YARA automatically checks all possible single byte XOR variations of string, revealing what attackers tried to conceal. So it'll be like this. Base 64 strings. Some malware encodes payloads or commands in base 64. With these modifiers, YARA decodes the content and searches for the original pattern, even if it's hidden in encoded format. So this is the string we're looking for, and it's gonna check for the base 64 version of it. Hexadecimal strings. Sometimes King Malware's code doesn't leave readable words behind. Instead, it hides in raw bytes deep inside executables or memory. That's when hexadecimal strings come to the rescue. Hex strings allow YARA to search for specific byte patterns, written in hexadecimal notation. This is useful when defenders need to detect malware fragments like file headers, shellcode, or binary signatures that can't be represented as plain text. So in this one, we are searching for strings, but looking at hexadecimal format. And then in this one, we can see, I'm assuming it's looking for hexadecimal, and then the question marks are maybe wildcards for hexadecimal. So these exact values and then wildcards is what I'm assuming. Regular expression strings. Not all traces of King Malware's malware follow a fixed pattern. Sometimes his code mutates. Small changes in file names, URLs, or commands make it harder to detect using plaintext or hex strings. That's where regular expression comes in. Regex allows defenders to write flexible search patterns that can match multiple variations of the same malicious string. It's especially useful for spotting URLs, encoded commands, or file names that share a structure but differ slightly each time. So for this one, we're looking for a URL, and it's in regex, so we want exact match for http then / and we want any number of any character, then it has to contain malware in it, then any number of any characters after that, and it's not looking at case sensitive. So basically, if a string contains http / and then anywhere within after that has malware, it would trigger the rule. And we've got PowerShell, any number of characters, -E and C. We're looking for any combination of capital letters A to Z, lowercase A to Z, numbers 0 through 9, and then symbols plus equals. Regex strings are powerful, but should be used carefully. They can match a wide range of data and may slow down scans if written too broadly. Conditions. Now that defenders of TBFC know how to describe what to look for using strings, time to learn when YARA should decide that a threat has been found. That logic lives inside the conditions section, heart of every YARA rule. The conditions tells YARA when the rule should trigger based on the results of all the strings checked. Think of it as the final decision point, the moment when the system confirms, yes, this looks like King Malware's code. So let's look at a few basic examples. We have match a single string. So if you set the condition to be the variable of a string, it has to be an exact match of them. If you do the condition of any of them, you might have multiple strings that you've defined, just needs to match one of them. And then there's all of them. So if every single string defined is matched with the data you're looking at, then that would trigger the rule. Then there's additional combinations of logic they can do, so and or not. So this one is if S1 or S2, then trigger the rule, and it must not be benign. So basically we need to match on either one of these strings but it can't match on this. So use comparisons like file size, entry point, or hash. So for this condition, it's looking for if any of the strings have been matched and the file size is less than 700 kilobytes. So YARA study use cases. The evil kingdom of Malheur used a Trojan known as Iced ID to steal credentials from systems. McSkitty's analysts discovered that the malicious files spread across Waveville shared a common signature. Same MZ header found in executable malware used by the Dark Kingdom. These samples were small, lightweight loaders designed to infiltrate systems and later summon more dangerous payloads. Let's write our YARA rules. So I've got information about the metadata about the rules, searching for strings where the MZ is this hexadecimal. We're then searching for this hexadecimal within it, and then we're searching for the string of Malheur located within it. And then the condition is that all of these need to be met, and the file size must be less than 10 megabytes. So our analyst saved this file named icedid_starter.yara and executed it on one of the hosts. As a result, we can see that one file was detected. So it was detected throughout the system, and it picked up this file here. We can use the man YARA command to find out what flags could be useful in our scenario. We find the following. -R allows YARA to scan directories recursively and follow symlinks. And -S prints the strings found within files that match the rule. Putting everything together, this YARA command recursively scans the C drive using the icedid_starter YARA rule file and can optionally display the matching strings when using -S. Next up is an interesting task where you'll need to create your own YARA rule. Good luck. So it's time to complete the practical cut task. The blue team has to search for the keyword TBFC : followed by an ASCII alphanumeric keyword across the Ubuntu downloads Easter directory to extract the message sent by McSkitty. So if we go back, let's open up a terminal and let's see if we've got, let's say man YARA, just to double check that that is available, that is working. Let's go into downloads directory, see if it's in here. So we've got Easter here, and let's create a new file using nano. We'll do tbfc.yar, and let's create a starting point by just copying that YARA rule into here. And then let's paste that with Control-Shift-V into here. Okay, so we've got a YARA rule, but let's go through and change it up. And let's change the rule name to be just TBFC. And as it's not really necessary, we'll delete all the metadata that came with it. And I've got strings like that. So the rule that we are searching for is the keyword TBFC followed by an ASCII alphanumeric keyword. So for that, actually, let's follow through with this first. So how many images contain the string TBFC? So let's create a string and let's just call it TBFC, and we will make this equal to TBFC like that and do no case. And then let's go through and delete the remaining strings and conditions. So put the condition back to here, and let's just keep it as all of them and then remove this last little bit at the end. So we should be able to save it. So let's do Control-X to exit, save modify buffer, Y to change it, and keep tbfc.yar. So if we do an ls, we should see the file still there. And the command to run it is YARA-R, and the name of the file tbfc.yar, and then /Easter. Okay, so it's found images containing that string, and we've got one, so just images 1, 2, 3, 4, 5. That was correct. So now, what regex would you use to match a string that begins with TBFC : followed by one or more alphanumeric ASCII strings? So we now need to go change our rule, and this time we need to use regex for it. So let's find the syntax for doing regex. So we've got TBFC, and we change this to remove the double quote, do a slash at the beginning, and then a slash at the end to indicate the start and finish. So we want TBFC : so these are the exact characters we're searching for, and what we want should be, I think, we add in the range of characters that we're searching for, so A to Z, A to Z, and then 0 to 9, and then closing square bracket. So I think it just said alphanumeric. So that should be all it's searching for is, and I think we use a plus for that. Let me do a plus. Can I do that? Okay, there we go. So regex starts with TBFC, followed by one or more alphanumeric ASCII characters. So I'm pretty sure plus is for that. Let's look up regex plus just to see. Actually, let's go to regexer and double check. Actually, that is something we could do. We could go in here, copy this. So Control-C on that. Hopefully that's in the clipboard now. It is. Then let's paste it into here. So character matches a T, matches B, matches F, matches C, and colon. They match any character in the set A to Z, 0 to 9, and the quantifiers match one or more of the preceding tokens. So let's type in TBFC colon. So currently it doesn't match anything, but if we add a 0, it's highlighted so it matches. So that means we did our string correctly like this. So Control X to exit, Y to save it, and then Enter to keep the file name. And then we rerun the same command as before. And we see we've got, appears to be the same matches, but we need to enter that YARA rule into here and do check, and that was correct. And now we need to find what is the message sent by McSkitty. So we need to rerun that command, and I think it was -S to see the output. So if we go in order of the file numbers, we have number 10 here, which has find. So go here, find. Number 16 is space me, and I have 25, which is space in, and 46, which is opsec, and space island. And that is day 13 of Advent of Cyber 2025 complete. Like this video, make sure to like and subscribe.